Section 2.3, Objective 2, solve a linear equation containing decimals. Example, we're going to solve the equation 0.4z minus 6 equals 1.2. Let's start off with the 0.4 here. 0.4 is the same as 4 tenths. Another way to say 0.4 would be to say 4 tenths. They are equivalent to each other. And 1.2 is the same as 12 tenths. So looking at these two fractions, I can tell that the LCD between these two fractions would be 10. So if we were to imagine this equation, instead of decimals, to be rewritten with fractions, we would be multiplying the entire equation by 10 to get rid of the fractions. Well, we can do the same thing with decimals. We can multiply with 10 and it will get rid of our decimals. So I'm going to multiply 10, I'm going to distribute to the 0.4z, to that minus 6, and to that 1.2. 10 times 0.4z is going to just give me 4z. 10 times 6 is going to give me 60, and 10 times 1.2 is going to give me 12. And now we're going to isolate the variable term by adding 60 to both sides of the equation. And that's going to cancel out my 60s there, and that's going to leave me with 4z equals 72. Divide both sides by 4. 72 divided by 4, that's going to give me z is equal to 18. So my solution for this equation is just going to be 18. So I'm just going to go ahead and write that inside of a solution set using a set of braces. Now you should always check your answer. You should never just believe that you did everything correctly. You might have made an algebraic or an arithmetic mistake. So we're going to check our work. We're going to substitute 18 back into the original equation to make sure that this is actually the true answer. All right, 0.4 times 18 is 7.2 minus 6, and we're going to see if this is equal to 1.2. 7.2 minus 6 is 1.2, so 1.2 is equal to 1.2, therefore this checks out. 18 is my actual solution for this equation. All right, let's go ahead and do another example. So we're going to solve the equation point 0.04x plus 0.06 times the quantity 10,000 minus x, close the parentheses, equals 480. So we're going to look at the decimals. 0.04 is the same as 4 hundredths. 0.06 is the same as 6 hundredths. So the LCD here is 100. So what we're going to multiply this equation by is going to be 100. $100, and then I'm going to open up here. I'm going to put the 100. I'm going to open up a set of braces. I'm sorry, a set of parentheses. I'm going to write the original equation inside the set of parentheses, and I'm going to multiply by 100. We're going to multiply the 100 to the 0.04x. We're going to multiply the 100 to the 0.06 and to the 480. Notice I'm not putting it inside the other set of parentheses here, the 10,000 minus x, because that's already being multiplied to the 0.06. So we're going to be left with 4x plus 6 times the quantity 10,000 minus x, close the parentheses, equals 48,000. Now we're ready to distribute the 6. 6 is going to get multiplied here with the 10,000 and with this minus x here. If I can draw this curve here. Good, yes. So we have 4x plus 60,000 minus 6x equals 48,000. Now we're ready to combine like terms. Our like terms here are going to be the 4x and that minus 6. So we're going to have 4x plus a negative 6 is going to give me negative 2. Negative 2x, because we need to keep that x attached to it. So we have negative 2x plus 60,000 equals 48,000. Now I'm going to isolate the variable term, so I'm going to subtract 60,000 from both sides of the equation. So I'll be left here with negative 2x is equal to 48,000 minus 60,000 is negative 12,000. Now we can divide both sides by negative 2. So negative 12,000 divided by negative 2 is going to give me 6,000. So I'm going to put that inside my solution set right here. It might not be a good idea to put a comma on inside the solution set because it might look like I'm maybe separating numbers there. So maybe in the future just not use a comma there inside the solution set. Let's check our work. Let's plug in 6,000 back into the original equation and see if it comes out to be a true statement. So we're going to have 0.04 times 6,000 plus 0.06 times the quantity 10,000 minus x, but instead of x we're going to substitute 6,000, close the parentheses, is equal to 480. Okay, so here I can work inside the parentheses 10,000 minus 6,000. That's going to give me 4,000. I'm going to bring down the parentheses because the parentheses not only represent grouping symbols in this case, they also represent an operation. They represent the operation of multiplication because the 4,000 is being multiplied to the 0.06. Let me copy everything down. So now I can multiply this out. 0.04 times 6,000 is 240. 0.06 times 4,000 is 240. And we're trying to see if this is actually equal to 480. So 240 plus 240 is equal to 480. So therefore, our solution checks out. The solution to this equation is actually 6,000. All right, that's it for this problem. Thanks a lot.